all of the identities that we've looked at so far, we've sort of taken my word for it that they really are identities. And we've just sort of dived in and then proved that they're identities. But if you have some sort of mysterious relationship between trig functions, you won't always know if it really is an identity or not. And you might need to show that it is an identity or show that it isn't. So let's have a look at an example. So here's an equation that might be an identity. Maybe it is, maybe it isn't. One thing you might do is just try to prove it, pretend like it is a genuine identity, and see what you can do to verify it. So you might start with the side on the left, cosine theta times tangent theta plus secant theta, and maybe distribute. So cosine theta times tangent theta plus cosine theta times secant theta. And then you might write everything in terms of sines and cosines. So it turns out cosine theta times tangent theta is sine theta, and cosine theta times secant is 1. And what the identity was suggesting we should have, or what the identity is suggesting is that our left-hand side is equal to sine squared theta plus 1. So, what we've proved is that it's equal if there's no squared here, but I mean, it seems like probably there isn't a way to just sort of magically produce a squared here and still have it equal to everything, equal to what we started with. But, there are so many hidden relationships between trig functions that it's actually hard to know if this actually is the same thing as sine squared theta plus 1 or not. It seems like probably not. But how can you be totally, totally sure? Well, so at this point we're suspecting that this is actually not really an identity. But to be sure it's not an identity, what you can do is think back to what an identity means. An identity is something that's true for every value of theta. So if we can find one value of theta where these two sides are different, then this isn't an identity. So if we think that this isn't an identity, let's try to find a value of theta that makes the equation false. If we can find such a theta, then we will be sure that this is not an identity. So the nice thing about trig functions is if you have a supposed identity that's really false, you shouldn't have to try too many values of theta before you stumble onto one that works. If these two sides really are different instead of the same, most values of theta will make them be different instead of the same. So let's just pick some values of theta. You might start with 0. On the left-hand side when we plug in 0, so cosine of 0 is 1 times tangent of 0 is 0, and secant of 0 is 1. Okay, on the right-hand side, sine of 0 is 0 plus 1. So actually it looks like these two sides are the same for theta equals 0. But 0 isn't, that's not very convincing evidence. This might be a coincidence. So let's try another value of theta. Maybe a value of theta that's a little more interesting than 0. How about pi over 6 maybe? Okay, so cosine pi over 6, that's root 3 over 2 times tangent pi over 6 is, that's 1 over root 3 plus secant pi over 6 is 2 over root 3. That's just the reciprocal of cosine. We want to check, is this equal to, let's see, sine of pi over 6 is 1/2. So that squared plus 1. Okay, now let's calculate here. So let's see, we have root 3 over 2 times, inside here, looks like we can just add these fractions since they have the same denominator. So 3 over square root of 3. Then we can simplify, and we get 3/2 for the left-hand side. For the right-hand side, 1/2 squared is 1 over 4 plus 1. That's 5 over 4. So these aren't the same. So we've found one value of theta where both sides of this are defined but unequal. So that means this supposed identity is false. Okay. So if you have a supposed identity and you need to tell if it's true or false, you might switch back and forth between trying to show it's true by doing some algebra with identities and trying to show it's false by checking values of theta. Usually, if it's false, you'll find a value of theta pretty quickly. If you have chosen several values of theta and this equation keeps turning out to be true, that's usually pretty good evidence that it's an identity, and so then you might work a little harder on the algebra to see if you can prove that the identity is true.